Welcome to topic 4, Z-test in Jamovi. The first thing that you're going to want to make sure you have done is that you've installed the module Z-test Viz in modules. If you haven't done this before, you can install modules in Jamovi by clicking the plus modules, and then if you go to Jamovi library, you kind of have to scroll down. It's not in any discernible order that I can really make out. You just have to go and look until you find the module that you're looking for. I already have this installed, and it is called Z-test Viz. So look for this and just install it. Once you have it installed, it will actually pop up under the MISC category. So this MISC icon will appear, and if you click on it, you'll see there is the Z-test Viz, one sample Z-test. All right, so let's make sure you have that installed before starting on with the rest of this video. So we're going to walk through an example and do a Z-test in Jamovi for this example. This is a pretty similar example to the kinds we've been looking at in lecture. Say it's known that in a Canadian population, the average IQ score is 100 with a standard deviation of 15. Say a teacher believes that the students in her school are particularly bright. So her research hypothesis is that the average IQ among her students is greater than the average IQ of 100 in the general population. In this case, then, the null hypothesis is that the average IQ among students at her school is not greater than the average of 100. And so she's got her research hypothesis, her null hypothesis, and say this teacher performs IQ tests on a random sample of 10 students in her school. So our sample n is 10, and we have these scores. Okay, so here's the 10 students, and there are their IQ scores. The first thing that we are going to need to do in this case would be to get the sample mean, right? The mean of those 10 scores. And we can do that. I mean, we could, just calculate them ourselves, but we want it to be lazy. We could just copy and paste these 10 scores into Jamovi, make sure it's a continuous variable. And then we could go ahead and just get the mean of those 10 scores. And we find the mean is 103. Okay, so the mean IQ for those 10 students is 103. And that's what we have done. We can conduct a Z-test to determine if this mean IQ is significantly higher than the general population mean IQ of 100. And we're told we are going to use a significance level, or alpha, of 0.05. Okay, so we're going to walk through these instructions, and we'll see that we kind of have to scroll over here to MISC. So analyses, MISC, one sample Z-test. All right, so this is a little bit different, this Z-test module, because instead of putting variables into windows, kind of, like we did in exploration, we were getting the mean, standard deviation, etc., like moving variables into windows, we don't see this here. What we see are some parameters, some input parameters, and we need to enter these numbers so that they match with our problem numbers. Okay, so this is our problem, right? We need to tell Jamovi what the sample mean is. Okay, so the sample mean is the mean IQ of these 10 students, right? So our mean is 103. That's what we're going to type in the sample mean window. Null population mean, and that is the mean of population 2. Okay, so to use the language of the 5 steps, the null population mean, the mean of population 2, which in this case is the general population. In this case, we know that that is 100, right? Because that was the IQ that's known in the general population. So we're going to enter that as 100. We are also given the null population standard deviation, right? This is in the Canadian population. The average IQ score is 100 with a standard deviation of 15. So our null population, in other words, population 2 standard deviation is 15. Our sample size, our n is 10, right? We said we have 10 students randomly selected from the population, and our alpha level is our significance level. Remember, significance level, alpha level, it's the same thing, and we're leaving that at 0.05. All right. One thing that you have to change here is see the alternative hypothesis. Another word for our alternative hypothesis is research hypothesis. Okay, so again, we use those terms interchangeably in statistics: alternative hypothesis, research hypothesis. Here you have to tell Jamovi, was your hypothesis two-tailed or one-tailed, and in what direction it's going if it's a one-tailed. So because our hypothesis is that the mean of the students in the school is going to be greater than the mean of the students in the general population, we are going to select one-tailed greater than. Okay. All right, and that's all we need. This is actually a really lovely module that Jamovi provides us with here. Okay, so I'm going to switch to my Word handout because I have this all annotated, but I just want you to see that what we have generated here in Jamovi by following the steps that I was just doing is going to give us this output, which is exactly the same that's on here, except like I said, I'm going to switch to the instructions handout because I have it all annotated. Okay, so let's walk through some of this. And we did this a little bit in lecture, so hopefully this is, looking a little familiar. The one sample Z-test results start off with giving you a table. And you have 3 pieces of information that we're going to pay attention to in this table, right? So the observed Z, it's the sample Z-score on the comparison distribution, okay? So the sample mean, which we know is 103, has a Z-score of 0.632. So the sample mean's Z-score on the comparison distribution is 0.632. And as we saw in lecture, that means that the sample mean of 103 is 0.632 standard deviations above the mean, right? Because it's a Z-score, it's a positive number. So 0.632 standard deviations above the mean on the comparison distribution, okay? The picture also shows the sample mean right here. It gives you a lovely little picture, right? We talked about this in lecture. The dark blue distribution here, that's the comparison distribution, right? The distribution of means. And the light blue distribution is the distribution of individual scores, okay? And this sample dot here is 103, which is 0.632 standard deviations above the mean on the comparison distribution. Okay, the standard error is the next thing that the table gives us, and it's just the standard deviation of the comparison distribution. Okay, so, and it has this right here. See the dark blue distribution, standard error is 4.74, that's up here. P-value is the most important piece of information that we get from this table. The p-value, remember, it's the p-value for this sample score. So okay, for this sample score here, all right, it is that's the p-value that would accompany this score. The basic thing to really remember here is that if this value, that is the p-value that Jamovi gives you, is less than our significance level, we reject the null. So for this example, our p is 0.264. What does that mean? What that means is the probability of observing a sample mean IQ of 103 or higher, right, which corresponds with a Z-score of 0.632, is, so the probability of that is 0.264 if the null is true, because remember, this is the null hypothesis situation. So our p-value is 0.264, or you could also say 26.4%. This is higher than our significance level of 0.05 or 5%. So we're literally just, all we need to do is compare our p-value with our alpha level. Okay? In this case, because our p-value is greater than our alpha level, we do not reject the null. We fail to reject the null, and our conclusion is that the sample mean is not significantly different from the null population mean. Okay, and we can also know this actually just from looking at the picture. If we know that the black dot is the sample mean, and the maroon shaded area here is what Jamovi calls the critical region, and what I've been calling in lecture the rejection zone, right? So the start of the rejection zone here, that would be the cutoff. Okay, there's the cutoff value, and So any sample mean that fell in that critical region, that rejection zone, would indicate that the null hypothesis would be rejected. In this case, see the black dot, the sample mean falls outside of the maroon shaded area, the rejection zone. So we know just from looking at the picture, seeing the sample mean does not fall within the rejection zone. We know that we would fail to reject the null. So you could just look at the p-value and notice that it is greater than our significance level, and that would lead you to the correct conclusion. You could also just look at the picture and observe that the black dot does not fall in the maroon shaded region in the rejection zone, and that would also lead you to the correct conclusion. Or you could just look at this information that Jamovi gives you. It tells you in a one-tailed z-test with alpha of 0.05, the sample mean is not significantly greater than the null population mean. All right, so this is a test that is pretty easy to interpret. And like I was saying, you could either just look at the p-value, or you could look at the picture to see where that black dot is in relation to the critical region, and that would give you your information. Okay. All that said, typically in the hypothesis test that we will see in the future, Jamovi doesn't give us the picture. Okay, all it gives us is something like this table. Okay, and so I want you to think about getting used to interpreting the results of a hypothesis test simply by observing the p-value and also whether or not it is less than the significance level. Okay, but this makes it nice and easy, and I really like how it visualizes it for you and just makes it very clear. I actually wish all the hypothesis tests in Jamovi did this kind of thing. Sadly, they do not. All right, I wanna play around just with a few things here in this z-test module in Jamovi just to help us better understand how hypothesis testing works, how the z-test works. All right, so I want to play around with a few things. So change the sample mean in Jamovi to 112. So just go into sample mean. So now say we're saying, we conducted another study and everything is the same except that our sample mean is now 112. Let's see what happens. Over. All right. So you're going to observe now how the black dot, see, there's the black dot, which is the sample mean. Now it falls in the maroon shaded region, the rejection zone or critical region. Okay. And now if we look at the observed Z, you can see that it's also different. It's 2.53, which means that sample mean is 2.53 standard deviations above the mean on the comparison distribution. Now we have a new p-value. So the p-value for this sample mean is 0.006. Right? So this means that the probability of observing a sample mean of 112 or higher, right, which corresponds with a z-score of 2.52 from 10 students, is 0.006 if the null is true. In other words, there's only a 0.06% chance of drawing a score this high or higher from the comparison distribution if the null is true. This probability is low enough to allow us to reject the null, right? Because it falls under the criteria of a low probability sample score, because this probability, right, 0.006, or actually let's be consistent here. So yes, 0.06% is less than 5%. Okay, 0.06% is less than 5%. And so then the correct conclusion would be to reject the null and say that the sample mean is significantly greater than the null population mean. So again, you could just look at the p-value, note that it is less than 0.05, or you could, in this case, you could just look at what Jamovi tells you is the conclusion. When we have a sample mean that is 112 in this situation, that is significantly greater than the null population mean. Okay? And you can also see it, the dot falls in the critical region. One thing to mention here, make sure that you keep in mind that the p-value is expressed in proportion, okay, not percent. So this is 0.006. You could also express it as 0.06%, but this number that Jamovi gives you is always going to be a proportion form. So for the significance level, the proportion form of the significance level is, right, 0.05. And so that 0.05 is what you're comparing to the number that Jamovi will spit out for you in the p-value. It's not the percentage. That's not what Jamovi gives you. Okay, let's do another one here. We're going to leave the sample mean at 112, but change the significance level, or the alpha level, to 0.01. Let's see what happens here. All right, so now we're going to observe how, and it's really hard to see. See if I can zoom in a little bit. The maroon shaded area changes, okay? It gets smaller, right? And that means that the cutoff has moved up the curve to a more extreme score. So now a more extreme score is required to allow us to reject the null, okay? Because the sample mean didn't change, it was still 112. The observed z-score stays the same, the p-value stays the same, and because the p-value here, 0.006, that is less than 0.01, that still allows us to reject the null hypothesis. Right? So this probability is still low enough to allow us to reject the null, even though we made the significance level more stringent. It falls under the criteria of a low probability sample score because it's less than 0.01 or 1%. All right, one last thing here. Now we're going to change the alternative hypothesis drop-down window to two-tailed. Okay, so we're going to change this to two-tailed. And let's see what happens. And we're mostly going to be looking at what happens to the maroon shaded areas, the rejection zones. You can barely see it now, right? It's just this tiny little area in here. And this is because we still have a 1% significance level, and we have to share that 1% significance level between the two tails, okay? So the shaded area here, the maroon shaded area, this is just the bottom 0.5% of scores and the top 0.5% of scores. Okay, so that's just a tiny region of the curve, and you can barely see it. All right, and so our Z and P, our Z score has not changed, but our p-value has changed now because now we have a two-tailed hypothesis, and the p-value is just calculated differently for that. And essentially, with a two-tailed test, you need a more extreme score on either side of the curve than you do with a one-tailed test. So to know what the correct conclusion is to this hypothesis test, you're going to look at the p-value. P-value here now is 0.011. That's actually just a tiny bit higher than our significance level, right? Our significance level is 0.01. Our p-value is 0.011. So actually, we are not going to be able to reject the null here, and the decision sentence says this, right? In a two-tailed test with an alpha of 0.01, the sample mean is not significantly different than the null population mean. And that's because, again, the p-value is just slightly higher than our significance level. Okay? And this is a way that you can see that to obtain a significant result with a two-tailed test, you need a more extreme sample mean, because those cutoffs get pushed up the curve or down the curve at the lower end of the tail. You need a more extreme sample mean to reject the null in a two-tailed test. All right, so just a couple more things with this video here. This is an important note. I actually touched on this before. Just remember that this module is different than the other hypothesis tests that you're going to see in Jamovi. It makes it really easy for you. Usually you don't get the picture, you don't get this sentence that tells you what conclusion you should make. All you get is a table that looks like this. And the most important thing you need to know, the thing that you need to observe in order to make your conclusion is that p-value, and compare it to your significance level, right? So when we do these hypothesis tests in Jamovi, typically that's what we will be looking at, is just the p-value. And remember, again, like I've said before, if the p-value is lower than significance level, we reject the null and say our results are statistically significant. But if the p-value is greater than the significance level, we can't reject the null, or we say our results are not statistically significant. So going from that assumption, let's say all we have is this table. This is how you would interpret the z-test output in Jamovi, using just the p-value to make the decision. Right, so the first thing you do, so you have your results here. You note whether the sample mean was lower or higher than the mean of population 2. In this case, let's actually go back to the original problem. So the sample mean was 103, right? And then we're using a one-tailed greater than test, and our alpha was 0.5. Okay, let's go back to that because that's the example we're going to work with here. All right, so here's our results. We note that, yes, the sample mean was higher than the population mean of 100, right? 103 is higher than 100, so okay. But now we're going to look at the p-value and compare it to the significance level to determine if that difference is statistically significant, right? That difference between the sample mean and the mean, the null population mean, is it significant? And our p-value in this case tells us that no, it is not. It is not significantly different. And so that's pretty much it. You're just looking at the p-value. After you determine what the result is, what I want you to get used to doing, and we're going to be doing this a lot over the course of the semester, is to write a description of the results of your hypothesis test in APA style. So APA follows a really specific format for reporting results of a study, and this is a little bit of a guide to APA style reporting. You'll see as we go through the rest of the semester that I'm almost always going to have you write up the results in APA style. And the format is very similar for all of the different tests, but there's more details that you have to add as the tests get more complicated. So what I'm providing you here is kind of very simple, and you'll see this same basic format in the future, just with expanded details. Okay, so first, what do? You provide a brief introduction to the research question, describe the method, just very briefly, indicate the N, and any other pertinent information about people in the sample. Then you're reporting the sample mean, as well as the known population mean to which the sample mean is being compared, and also the known population standard deviation. So let's do this part first. Actually, I've got it all here. So that's this part here, right? So just provide a brief introduction to the research question. That's a teacher hypothesized the students at her school were smarter on average than the general population of children, which is known to be 100 with a standard deviation of 15, to test their hypothesis. This hypothesis, the teacher took a sample of 10 students, right, reporting the N, 10 students from her school, and found their mean to be 103. Okay. So that's that part. All right, next, this is where you get into reporting the formal details of the test. You indicate that a single sample z-test was conducted, right? So you always report what test it is that you were doing. You note the significance level of the test and whether it was one or two-tailed. Okay, so that would be this sentence here. Different color, right? She compared their mean IQ to the known population mean IQ using a one sample z-test, or a single sample z-test. Same thing. And this next step here is where you indicate whether or not the results were significant. And so kind of exactly what you write depends on whether or not the results were significant. Okay. Sorry, I got ahead of myself there. You report now you're reporting the technical details of the test. So this is where you report the Z score that you get in this little table here and the Z score's exact p-value. Okay, so that's that part there. right? And it's important that you put it in this order, Z first and then the p-value. All right, so the next part is just saying, so for this example, the sample mean was not significantly higher than the general population mean. The research hypothesis was not supported. Okay, so again, you kind of, depending on whether your results are significant or not, in this case, the results were not significant, right? Because our p-value is greater than the alpha level. So we're following this. If results were not significant, we say the sample mean was not significantly higher, in this case, not significantly higher, right? Because that was our research hypothesis, was that the mean would be higher. So we say the sample mean was not significantly higher than the general population mean, and the research hypothesis was not supported. That's the last little part there. Okay. So that's how you would write up the results of this Z-test in APA style.